Okay, so this is the bottom of page 3 that we're going to be looking at right now, talking about the combined gas law. That's this equation that we have. And before you worry about it, no, you do not have to memorize it. It is on your equation sheet on the side that starts with atomic structure at the top. The second section is behavior of gases, and this is the third equation down. And you'll notice that it has words explaining what all these variables mean, but the equation that we really need to worry about is over there at the right-hand side. When P, V, and T are all things that we've seen before, that N does stand for moles. And the most important thing to know about this equation is that we use this equation when something about our gases is changing. So I have one pressure on one side, but then I have a new P2 on that other side because the pressure is going to be changing in these situations. And in fact, right underneath this equation on your notes packet, it has a big old paragraph, and the last sentence is the most important. It says, if it, meaning any of our variables, does not change, you do not include it in your calculation. So this calculation, this equation, is only for things that are changing. If it specifically says that it's staying constant, not changing in the problem, or if they don't mention that variable at all, you can leave it out of this equation. And that's actually what you see below this equation in the gases equation part are 3 different versions of this where we've left out some variables. That first one, evidently our moles and our temperature weren't changing, and all we're left is that P1V1 equals P2V2. But we really aren't going to need any of those equations if we remember that this big complicated looking equation can get simplified down. Anytime we don't see it, or if it says that it's not changing, we can leave it out. So the most important thing is to read our questions carefully and make sure that we're finding the right numbers and plugging them into the right place, because we got the equation, we've got the numbers. You just need to do that work in between. The other thing we should keep an eye out for, and it doesn't happen too much, is to make sure that the units match. Both of the pressures on both sides have to have the same units. Volume has to have the same units. It doesn't matter what those units are as long as they're the same before and after. And of course, temperature is always going to be in Kelvin for these calculations. So just those are automatically going to match. Now, the best way to get better at this is to work out some problems. And how I like to start, especially at the beginning when we're first working these out, is by writing out each of my variables and then reading through my problem and trying to find them. So that's what I'm going to do here. So it says that I initially have a gas at a pressure of 12 atm. So that is going, I'm actually going to change colors just so that these numbers stand out. 12 atm. And a volume of 23 liters, so that's my volume 1, 23 liters, and a temperature of 200 Kelvin. And then I raise the pressure to 14 atm, so that's my P2, 14 atm, and increase the temperature to 300 K. So that's my T2. And then it asks, what is the new volume of the gas? So V2 is what I'm looking for. And if you notice, it doesn't mention moles at all. Not a single place in that problem. So we don't have an N1 or an N2. We're not going to need it. We're just going to put everything else in there. So now I'm going to set up my equation. I'm going to put my P1, 12, times my V1, 23, over N1, which I don't have, and T1, and then set that equal to P2. My V2 is what I'm looking for. You might want to put that as an X. I like to actually write out the variable so I know what I'm solving for. Helps me with my units later. Over my T2, because there's no N2. I don't need to worry about it. So now at this point, there's a lot of different ways of solving it. So I need to see this initial kind of work setting it up, putting these numbers in. Then how we get to the final answer is completely up to you, how you use your algebra. What I would recommend, though, is that we cross multiply. So I like to start by multiplying this diagonal, so I'm going to do 12 times 23 times 300, and that equals 82800. And then I'm going to multiply that other diagonal, 200 times 14 times V2, so that's 2800, and the V2, or the X, however you want to write it. It's really important that you write that down, because writing that down helps you know where you're going to be dividing. We are always going to be dividing by whichever number is with that V2, that number there. The thing I'm trying to find, I need to get that on its own. By the end, I want to say V2 equals. I just want to have V2 by itself. So I'm going to divide by 2800. Of course, I have to do it on both sides. That means this cancels out to give me V2, and I just need to plug this into the calculator to get my answer out. So we're doing that divided by 2800, and my answer straight out of the calculator is 29.5714, but looking back at all the numbers that I plugged in up here, originally I had 2 sig figs as my least number of sig figs. This 200 and 300 each had a little decimal after it to keep those as 3. So out of all of these numbers that I was using in my problem, the least number of sig figs was 2. So I want to come back here and just keep these 2 sig figs, but the 5 is going to round the 9 up. So my final volume is going to be 30 with a decimal point to keep that as 2 sig figs. And then my units here are going to be liters, because, like we said before, the units have to match before and after our reaction or our equation. And so because my units for V1 were liters, then this is going to be liters. If they were milliliters before, I don't have to do anything special. I just do it, and the answer I'd get out would be in milliliters. So 30 is our answer to this first problem. Now, second problem has a couple of little twists, so I'm going to go ahead and clear this out so that I can work on that second problem with a clean slate. And I'm going to annotate this and find my variables a little bit differently this time, because sometimes it just takes up a lot of space. I almost ran out of space on that last problem. So to save a little space, sometimes what I like to do is underline or circle those numbers, and then I can label it right there, right by the number, so I don't have to rewrite everything out. So this is my first volume I see, so I'm labeling that V1. And the next number I see, this 2.3, is a pressure. So that's going to be my P1. And then here is my T1, although I emphasized before that we have to make sure that all of our temperatures are in Kelvin. We cannot calculate with Celsius. So I need to add 273 to that, and that gets me 307 K. So I found that temperature, but then I went ahead and I converted it so that I won't accidentally plug in that 34 number into my calculations. Now, keeping going, I raised the temperature to 50 degrees Celsius, so that's going to be my T2, and 273 plus 50 is 323 Kelvin, and lower the pressure to 1.5 atm, so that's my P2, and then it's asking us what's our new volume. So once again, I'm looking for my V2. Now, I don't have enough space to set that up, and I kind of did that on purpose because I don't want to. I'm not going to. We're solving for the same thing, that new volume, and we've got some different numbers, but I went through and helped you find them. So I want you to sit here and set everything up, cross multiply, divide, and when you get your answer should be 27 liters. It's going to be a little bit bigger than that and round down to 27 liters as your answer. So if you get that as your answer, then you know you've done it right. So there's our 2 problems at the bottom of page 3. Come in if you have any questions or need more help with this, especially cross multiplying. I want to help you get there. Good luck.